It was so the video is called "Don't Try This at Home," and you shouldn't try those things. But we're not going to talk about that today. We need to do some math because we only have about a half hour left. If you did not write this down yesterday, your homework's kind of random today. I picked those problems intentionally. So those are the ones that I thought were really good problems that we should hit, and the other ones I don't want to make you do and spend your time on. So instead of saying, like, do it all, that would be a jerk move. So that's going to be up on the TV, but I got an intro video for you that relates to what we're going to be doing today. So fun story, and 8th graders didn't even know this because this wasn't true last year. I enjoy slacklining, which is what this guy is doing, except I can't do tricks because he's awesome and is sponsored by Red Bull. I just try to get from one end to the next because it works your core. But we're going to start talking today about a tightrope walker. And his name's Cecil. So we can imagine that this gentleman in the Red Bull shirt is named Cecil. And one thing about when you're on a slack line is you have to keep your balance so you can see his arms are up and everything else. But sometimes you can't keep going forward and you got to take a step back for a moment. Or sometimes you turn around and you go back and then you turn back forwards the right direction. So we're going to use this kind of like slackline-esque analogy. And they use a tightrope in the CPM textbook, but slack lines are a lot more fun than tightrope because slack lines are slack and they bounce. So like I'll be in the middle of the slack line, my buddy will bounce on the end and mess me up. But he's way better than I am, I'll tell you what. I don't have good enough insurance to try all that stuff. But we're going to talk about these movements as positive and negative distances spanning an area. So maybe we can pull up some more of those videos later. But today's lesson is 221, and we are going to be talking about composing integers. Composing means putting together. So we're not writing music. Sorry, not composing like that. We're composing integers. Now, if you want to get real fancy, you could write composition of integers. That's the other tense of that word. So, units of length can be placed one after another to end up making an entire distance, right? Because if I want to talk about me getting to the door, I don't think I can just like jump to the door, right? I might take a couple small steps and a big jump and a couple little guys, and then I realize I forgot something and I walk backwards, and then I turn around and I keep going this way, and then I realize I want my coffee, so I get that, and then I turn back around and go this way, so write different directions. No, right? I've always had that issue. So that's exactly what we're going to talk about today, but we're not just going one direction. So negative numbers, right? Negative numbers are a really weird concept because it's hard for our brain to understand what like a negative means. So we're going to start this as just the opposite direction as what we're trying to travel, right? So if I'm trying to go to the door, going that way is negative. It's bad. It's the opposite of what I want to do. But depending on the moves that I can make, I might not be able to get exactly where I'm trying to go with only certain positive moves. I might need to implore or use some negatives. So Cecil is trying to get from point A to point B. He needs to land at B to bow. But the funny thing is, he can go past B, right? He can go onto the platform, but then people can't see him very well. So he needs to come back to point B to take his bow, right? Just play along with me. I know some of the story is a stretch. So if he turns around and makes a move in the opposite direction, he is going to be making a negative move. Even though he's still traveling a positive distance, right? You can't travel negative distances. Like, even if I go backwards, I'm traveling a positive distance in the negative direction. So your task, work with your team to find different combinations of the lengths given in parts A through E, so it changes depending on which length you're trying to make. That will allow Cecil to move from A to B, and then, when you think you have it, I will give you the opportunity to come up and try it. So with a length of 24 feet, I first went 2 forward and then 2 backwards, and then 4 forward, 4 forwards, and 8 backwards, and 10 forward. You get the idea, right? So when you think you have the combination of positive and negative moves that will get you the exact span given here, you can come up and do it on the computer. I'll probably just have you do it on my computer as opposed to like tapping on, well, you might be able to just use this. But I got to clear out the old ones. So your first task is try to go 24 feet only given those lengths. And you can only use positive moves if you want, but sometimes we might have to use some negative moves. And I think on this one I only make you do it one way. Yeah, we're not going to do two directions at the same time. Alternatively, if your group would like, you can also, now we're not going to do 33 at the same time. Let's do 31 real quick, and then we'll move on from there. So this is 31. If you want to number it in your notes. So first, they start kind of easy, then they get a little bit harder. I need to clear all this. First length is 24 feet, 2, 4, 8, 10 moves. I can go positive or negative direction. Cecil's very stumbly this morning. You guys should do your work, not watch them do it. He can go past the 24, but then he has to come back. He has to land at the right spot for his bow because of the camera.
You have to use every one of those lengths.
Nope. So, and that's why I show you the slackline video, because people are like, how could you move 10 feet? Well, that slackline dude, if he takes a jump on the slackline and gets the launch, like, he could move 10 feet. Now, it might be, like, kind of sketchy, but a lot of those guys, that's why they'll land, like, on their chest or on their back or something, so they have more of their body to, like, land on as opposed to, like, trying to land on a foot. All right, so A's easy, right? How could we go 24 feet? Who can tell me? Yeah, Mallard?
I did 10 plus 8 plus 2.
10 plus 8 plus 2. That's not 24.
Oh, 4.
And 4 more, right? That will get us to the right location. Let's check. Yay! Any other ideas?
No.
What if I go, yeah, Connor? 10, 10, 4. Yay! Now what if I go, like, 10, 10, 10, 8, 8, 4, 2, 4, 8, 4?
Yeah.
Cecil dancing. Woo! So, although this was really complicated, it works. Now here's the trick. If we wanted to make this easy, we could just put all the positive moves together and all the negative moves together and just look at them all like, here's all the positives and all the negatives. So, with your team, figure out B through E. I'm only going to give you like 2 or 3 minutes. Do you think you have it? I'll just do these class together. So take like a minute, half, 2 minutes, try to figure these out. Then I'll call on random people to give me the lengths you decided and whether they are positive or negative.
So you can use it more than once.
You can use it more than once, and you can use it positive or negative. I do. Why are we strict, guys? One, I have a jar full, and if it's empty, now do you want me to give you one or borrow one? Then you can have a mechanical 0.9 lead high class pencil right there. But 0.9 doesn't break as easy. I swore off 0.7 last year. Said I'll never buy 0.7 again because I would break it.
Wait, can I use it twice?
Yeah, you can use numbers twice, and you can use them positive or negative. You can actually use the numbers as many times as you want. Those are just the lengths that, like, the moves he's making.
Yeah.
Write them out. Make sure they work. Don't just discuss. Write it out and test it. Make sure it works. We write them out, check them.
Wait, you can do it.
You want right here? You got 17. What about 15? Please make sure you put what it equals. Don't just write out the moves you're going to use. Put at the end what it equals. Like the length we're actually going for.
Yeah. No, you have 7 plus 11. 7 plus 11 minus 30.
All right, who can give me our move of 17 feet? Crap. I need to get the other length. I forget how to work this tool.
No, now you move the little red dot.
Do
Oh.
I think it's right over here. Yep. All right, 17 feet. Not Mallory. OP, what do you got? Aha, 10 plus 2 plus 2 plus 3. He makes it.
Yeah.
Nice. All right, let's try. Well, give me one more for 17. Different than that. Quinn? Different than what we had. Ooh, 10, 10, and a negative 3. There we go. Using a negative move. Connor, do you have one for the next one? Because I got to save time and move on to the 15 feet. You got a solution for 15? Positive or negative? Positive. 4 negative. Ah! Cecil fell off! You ended up at 16 feet, not 15 feet.
Oh, wait. And he's blindfolded? Why would he be blindfolded? That's not
So hold on. Shh. Hold on, take it back. Connor, hit me with it again. Sorry, guys, I cannot hear Connor. Is it 1 11 or 2 11s? Okay, 11 then. Okay. Ooh, because this gets us real close, but then we bump 3 more, 4 more back. Let's see if it works. There we go. On 38. Is that? Sorry, that's from a different. Sorry, that's an extension. 23, right?
Yeah. 27.
Fine. Breeden?
12 plus 19 minus 4.
12, 19, negative 4. Nice. One more on this. 19 and 8. Nice. All right, so I think we get the idea, right? Positive and negative numbers can be put together to make different spans that we want. So, We're just gonna keep moving on. I actually think we might be skipping the rest of the lesson.
Really?
What? Pretty much. So, the biggest thing for us to understand here is we want to look for two different things when we're solving these problems. One, if we have any additive inverses, those can pair up real easy because additive inverses do what, Clint?
Additive inverses, yes, my favorite. They.
So are you with me or were you off task?
You add and then you reverse.
So were you with me or were you off task? A little off task, right?
I
Additive.
don't know what those are.
I know. That's why I picked them, because I could tell that you were off task. Beware, guys. If you are off task, it's real easy to see. You paint a target on yourself, quite honestly. Additive inverses are opposite numbers. Like a 4 and a negative 4, an 8 and a negative 8, a 3 and a negative 3. Those moves are opposites of each other. Right? So when you guys came and I showed you my whole like forwards, backwards, like a lot of you probably looked at it and you're like, what the heck is he doing? Well, yeah. A lot of that was pointless because if you have additive inverses, you end up exactly where you were before. The other strategy, move all of the positives, group them together and put them together, move all the negatives, group them together, and then put the positives and the negatives together. Here's my analogy. Who has seen essentially any Marvel movie? Or any superhero movie, really? There's always good guys and bad guys, right? So when we walk into an addition situation, what we're honestly looking at is who's going to win the fight. Okay, our positive numbers are good guys. Our negative numbers are bad guys. And any number that's trying to subtract is actually a bad guy in disguise. So if you had the expression 7 minus 3, that's a lie. That is not two good guys. That is a good guy and a bad guy in disguise because there's no such thing as subtraction. Right? We watched that video from PBS Kids like 2 weeks ago or something about like the Matrix and everything. And subtraction doesn't really exist. Okay, well maybe we'll watch at the end of class. I thought we did. Subtraction is really just adding a negative number. So when you see subtraction, we should really rewrite it as addition of a negative, just like they have written here. So here we have two good guys of strength 10. And then we have a bad guy of strength 3. So the good guys team up. They make 20. And then the bad guy tries to take them on. Who wins? The good guy by how much power? And that's how you add. You make good guys and bad guys fight each other. All right, next lesson.
This is a good way to think of it.
Yeah, welcome to the compressed 7-8 class. All right, now, not only are we adding integers, I guess I should maybe capture that or something. Ooh, that's loud. Integers are entire numbers. So I want you, I don't even care if you write adding integers and rational numbers, whatever. Integers, excuse me, the beginning of that word, inta, or just int, I want you to think entire value. Integers, entire value. Rational, what word's at the root of that? Ratio. Right? Ratio means it can be written as a fraction. Ratio is just another way to talk about a fraction, which is another way to talk about division. So rational numbers can be written as fractions, which all integers can be written as a fraction. Like 4 is an integer. How do I write 4 as a fraction? No. 4 over 1. Be careful, don't fall in that trap. Connor. Oh, we're not there yet. We're not there yet. So, okay, fine. Because he asked the question, I have to answer it. All right, so Connor asked, now what happens if we have like 20 minus -3? Good guys, bad guys, right? But instead, if the bad guy decides he's not really a bad guy, right? He has like a turn of heart. We take away that evil, and actually there's like no middle ground. We got to join one of the sides. So when we take away the bad guy, he actually joins the good guys. And the good guys now have a power of 23. Because they brought Luke back to the, I don't want to ruin anything. I know that's Star Wars, which is not Marvel, but is now owned by Disney, who owns everything, essentially. Alright, so, hold on, I gotta check what questions we want to do. We're doing 42, A through D. Hey, so I challenge you, these are harder, right? They're not all whole numbers, there's positives and negatives, and there's partials. Hey, Simon, sorry I'm talking about. If you need to talk and announce something for the whole class, let me know, I'll let you talk to the whole class. So can you just scooch away maybe to make it so he's got plenty of space? I mean, either of you, but yeah, I know we're kind of close to each other. Okay. I mean, is that really, like, can you just move so he doesn't push you? So really my question is, can we take care of it without my intervention? Or do you need my help to figure this out? Okay. All right, so A through D, if you get to E and F, sweet, awesome. But we're really just going to talk about A through D. I will give you, I want to challenge you, 3 minutes. Oh, you only have 4 problems. That's like 45 seconds a piece or something. I'll give you more time. Remember, the good guys and the bad guys want to team up with their team before they fight each other. Good guys with good guys before the fight, bad guys with bad guys before the fight. Anybody? West Side Story? No?
No.
Sharks and Jets?
No.
Good guys, bad guys?
Do a little bit.
They all like snap when they're coming into a fight.
Yeah.
And it's very dramatic because they're coming at each other snapping. It's like, guys, you're fighting? Maybe I'll
You're
pull it
fighting with your fingers. Oh, no, I've seen that.
I am going to pull up the subtraction
Like,
video.
I can't tell how.
It's a great, if you ever get the chance to see West Side Story, do it. Are you sure we didn't watch this?
Yeah.
This whole thing
No.
with the Matrix and the people?
No.
Are you sure? Okay. Alright. Stop what you're doing then.
Excuse me, I'm doing the math.
I mean, you can keep doing your math when I'm turning the lights off.
But can you put the math up on the...
He already did.
No, that's... Here, I'll move it.
No.
Hold up, I'll move it.
Oh my gosh, PTSD was my childhood. And it's
Yes.
Alright, so check it. There's no such thing as subtraction.
What?
Hold on, sorry. My computer was all the way turned on. So, if you've ever seen The Matrix, this is kind of a spoof on The Matrix. And actually, I'm going to stop recording real quick because I probably can't use their video. So, if you want to watch this video, go over to PBS Math Club and check it out.